Happy Tuesday, y'all. Um, Once again, I'm in quarantine. Uh, it's kind of boring. I shouldn't say kind of, it's really boring, but it is what it is. We're doing it virtually this week. Omega, you're in class today. You have Mr. Anderson, Mrs. Anderson's son. He has my email and all my contact information. So if you need me, just let him know and we can set up something so that I can zoom in with you. You're probably going to want your headphones for this one because you're going to be listening to my video in class. Or you could turn on closed caption. I know Delaney does that sometimes, and that helps her. So your choice. Yeah, so without further ado, I guess let's get into it. Omegas, sorry I can't be there with you today. Hopefully the day goes by quick. Um, but let's get into the math. Today we're subtracting again. Um, and I don't know if any of you noticed, I skipped lesson four accidentally. I just, quarantine brain, I just thought that we left off last week on lesson four. So we'll kind of circle back to that tomorrow. Um, Maybe we'll see how today goes. Check your exit tickets. So today we're subtracting again, but the numbers that we're going to be working on, the fractions, are going to be greater than a whole, but they're going to be between one whole and two wholes. Um, so just predicting without looking at the word, there's going to be some regrouping. So let me pause it. Let me minimize my face so you don't have to look at my quarantine face anymore that I haven't showered. And we will get working. So let me minimize and pause and we'll get going. All right, you ready for this? I was right there. Whoops, I didn't mean to minimize my screen. Sorry, you probably didn't minimize for you. Um, I apologize because I wish we did the lesson four, which is the same thing except adding um, fractions greater than a whole between one and two. But um, make sure we circle back about that. So I apologize for that mistake. But today, let's go ahead and get your whiteboard markers out. Remember, you're going to have to pause me multiple times probably today to keep up. 1 1/3 minus 1/2. So the question that we have to ask ourselves, just like when we're ever subtracting, is is the numbers ready to work with? Sometimes teachers say, is the top ready? So can we subtract the fractional parts? Is there enough thirds there to subtract 1/2 from? Well, I don't know either without creating common units. So that's the first thing that we have to do. Now, there's ways that you can just convert the thirds. Um, Actually, let's not even worry about that one right now. Let's just convert the entire thirds. We're going to convert this whole thing. Well, that's a bad highlight color with that background. We're going to convert this whole thing into thirds. And then once we have it into thirds, then we can think about renaming it. So let's think about how many thirds that is. Well, let's go ahead and draw ourselves some area models for this thirds. Well, it says it wants thirds, so let's give each rectangle thirds. Well, it said one is one whole. This is one whole, but it's 3/3. And there's only 1/3 left over here, but this is still one whole. Okay. Let me change colors and let me show my 1/2. Now the question is, how do we create these to be equal units? Now this is where we go from the last couple lessons. We count by our denominator, the unit, the multiples of whole units. So 3/3, 6/3, 9/3, and then we think about how many come by our halves, and if we have 2 halves, 4 halves, 6 halves, well, each of them would be common at 6. For thirds, we couldn't cut that once, and for halves, we need to cut twice. So 1/2 is equal to 3/6, and 1 1/3 is still 1 but it's 2, 6. And this is where I was saying that we're going to need to convert, because if we rewrite this sentence, let me just convert it up at the top. 1 and 2, 6 minus 3, 6. Is there enough 6s to subtract 3 from? Well, the answer is actually yes, but right now, as the number is written, there is not. But there is a way if we convert our 1 whole back into 6s, and we already see that it's already in 6s as our 1 whole, right? Because we drew a picture to show that. Well, 1 whole is 6 6s, so if we really think about that, we wanted to regroup from our 1 whole, well, that would be 6 6s plus 2 6s minus, oops, let me put the parentheses, minus 3 6. Well, let's do what's inside the parentheses. Well, that would give us 8 6. Sorry, I had to move down over here. 8 6 minus 3 6. Well, then our answer is 5 6. So I know that some of you will be able to do that without the area model. Let's make sure that we're practicing drawing the area model for these lessons. I promise you won't have to do those models every single time unless they specifically ask for a rectangular fractional model or an area model, okay? So let's go ahead and try another one. Let me clear this page. All right, we'll do a couple more quickly, and then we'll go on to our problem set together and see how we did. So let's write this fraction down. 1 1/5 minus 1/3. Okay. Well, let's go ahead and draw a rectangle to show the 1 1/5 first, right? So fifths needs 4 cuts. And it was 1. So this whole thing's filled. So this is 1 whole. Whoops, missed my line there. 1 whole. And then another rectangular part to show the fifths. Oh, let me just add another piece onto there. And now I have 1 1/5 showed as my rectangles. And then we got to think, okay, now we're taking away 1/3. So how do we get thirds into fifths to be the same unit? Well, let's really quickly create our 1/3 box just to show it, now we're not using these models right now to subtract, we're just using these models to help us get to common units so that we can then work with them. So we got 1 1/5 and 1 1/5, and then we got 1/3 over here. So let's count by our units. 5 and 5 fifths, 10 fifths, 15 fifths, 20 fifths. Okay, I already seen one that's a multiple of 3, but let me count by my 3s. 3/3, 6/3, 9/3, 12/3, 15/3. There it is. And we're looking at 1, 2, 3, 4, 5 groups of the thirds, so 4 cuts. Okay, and that looks like it gives us 1, 2, 3, 4. Yeah, that makes sense, because if we multiply, if each one is going into 5 groups, we're multiplying by 5, so that makes sense. All right, and then over on the fifth, it looks like it needs to be 1, 2, 3, 4. Oops, I'm doing the wrong side. 1, 2, 3 groups, so 2 cuts. 1 cut, 2 cut, 1 cut, 2 cuts. And then I can see that this is now 15 fifteenths. I shouldn't have wrote it like that. I should have wrote equals, not right on top of it, equals 15 fifteenths. And then our 1/5, each group got cut into 3, so we're multiplying it by 3, should show us 3 15ths. 3 15ths. Now, if you wanted to use the area model to show the multiplication, you could. Now, we're taking away 5 15ths, right? So if I just crossed out these x's, 1, 2, 3, 4, 5, I could solve this math problem that way. And then I could count what's left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Should have 13/15 left. So you can use the area model just like we used the arrays in pictures in the lower elementary grades. However, I like to just use the numbers because I feel like drawing the pictures and Xing them out just sometimes is a little bit more challenging for my brain just because I feel like it gets too busy in those models. And if that's the same for your brain, then and you'd rather just use the numbers, that's okay too. Like that's why we love math is that there's multiple ways to solve things. So since we're going to be, I want to show it also in a numerical sense, I'm going to rewrite it down here at the bottom in 15ths. Well, 1 and 1/5 minus 1/3 really is 1 and 3/15 minus 5/15. But I want to regroup that 1 and 3/15 so that I have enough 15ths to subtract 5 from. So I need to combine 15/15 and 3/15. So this is really equal to 18/15 minus 5/15, which is going to give us 13/15, which is exactly the same as Xing out on those pictures showed us, right? All right, let's go ahead and do it again. Let's try 1 and 1/2 minus 2/3. Whoops, 1 and 1/2 minus 2/3. Okay, well, let's go ahead and draw some models for the 1 and 1/2. There's the 1 whole. I'll label them here in a second. So here's 1 whole. This is another 1 whole, but this is 1 and 1/2. Whoops, not 1/3, 1/2. And then over on the other side, we're going to do 2/3. So we're going to cut it twice to create thirds. There's my 2/3. Let me label that as 2/3, and let me also label the top as 1 whole. All right, so we need to subtract 2/3 from 1 and 1/2. Once again, we got to think of a common unit. So let's count by 3/3, 3, 6, not yet. Well, let's just stop there because I already know that 6 is where we need to be. 2, 4, let me change color so it doesn't look like it's 23 and 46. 2, 4, 6. Yep, that's the one we need. So halves need to be cut into thirds to get sixes, and thirds need to be cut in half to get sixes. So we can see that 1 whole is 6, 6. 1/2 is 3, 6. 2/3 is 4, 6. Now that we have all of that information, we can choose if we want to subtract by using our area models or if we want to use the numerical model. So if you want to use the numerical model, you're just going to want to rewrite the sentence. So let's rewrite the sentence as sixes. And so we have 1 and 3/6 minus 4/6. And what we would want to do then is regroup that 1 whole into our fractional unit. So it's 9/6 minus 4/6. Now I'm going to stop there. I think you guys can see that answer, but I want to also prove it on our models. So it looks like we have 4 6s that we're taking away from the larger whole. So let's go ahead and show that with little x's. And I'm going to use a nice bright color. I'm going to use green to show that. 1, 2, 3, 4. We've just taken away 4 6s from the number, and we see that we're left with 1, 2, 3, 4, 5 6s. Is that what we would have gotten if we subtracted 4 from 9? Absolutely. Great job. All right. Let's go ahead and do one more, and then we'll go into the problem set. Actually, let's just go to the problem set. I think the video is already running its length right now. All right. So Mr. Anderson should have probably already passed out the problem set, and if he hasn't, just go ahead and please ask him to get you a copy. Let's get our names on them, and then let's start thinking about the directions. So for the following problems, draw a picture using the rectangular fraction model and write the answer. simplify the answer if possible. Don't worry about that direction, because the way that we're choosing to find common units, it gives us the simplified answer already. So we kind of make our work a little easier by doing a little extra work at the beginning to find the common unit. So let's go ahead and let's look at the whole page just to notice what we're working with. There's 4 problems on this page. I'll do 2 of them with you and then unleash you for 2 of them. 2 problems on the back, same thing. I'll do 1 of them with you, and then the word problem, we'll do it together, and then I'll unleash you on the exit ticket. All right, so let's get rolling. Let's do B together, and we're going to do 1 1/5. So let's go ahead and create the model for 1 1/5 first. So 4 cuts creates fifths. So this is my 1 whole. Remember to pause me if you need to, because I go fast. Remember, I know this math. You guys are learning it, so that makes sense. All right, so there's 1 whole. There's another whole, but showing 1/5. All right, so underneath that, I'm going to draw my other area model because it's, I'm running out of space. So this is thirds. And there's my 1/3. I'll label off to the side. So, and this is 1 whole too. All right. So now let's start thinking, what's the common unit? Well, let's count by 5/5. 5, 10, 15, 20. Now, which one of those would be a multiple of 3? Well, if you can't visualize it, let's keep writing our 3/3. 3, 6, 9, 12, 15. There it is, 15. We're looking at 15. So thirds need to be cut fifths need to be cut into thirds, and thirds need to be cut into fifths, it looks like. So 1, 2, 3, 4. 1/3 is equal to 5/15. Now that makes sense, right? Because if we cut each third into 5 groups, that means we're multiplying the top and the bottom of that fraction by 5. 1 times 5 is 5. 3 times 5 is 15. Good. Now, same thing for our fifths up here. We need to cut it into thirds, it looks like. And we need 2 cuts for thirds. 1, 2, 1, 2. Now we cut each group into 3. So we're basically saying multiply by 3. Well, 5/5 times 3 would be 15/15. And 1/5, if we multiply the top and the bottom by 3, it should give us 3/15. Now this is where you're going to choose if you want to use the numerical method where you're just rewriting it numerically and subtracting, or if you're going to show the subtraction by putting X's in your area model. Let me change colors so that I can do the X's. 1, 2, 3, 4, 5. I've subtracted 5 of them. Now let me rewrite the sentence. Well, 1 3/15 minus 5/15. And then we have to rewrite the sentence one more time, combining the 1 whole into the 3/15. So that's going to be 15/15 plus 3/15. So 18/15 minus 5/15. And that should give us 13/15. Let's just double check our area model. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Absolutely. All right, let's go ahead and do D together, and then I'll let you do A and C on your own. All right, let's go ahead. 1 2/5, so I want to create 1 whole. 4 cuts gives me fifths, so there's my 1 whole of 5/5. 1 whole and 5/5. And then I'm going to do another area model showing fifths again, right? And I'm going to show 2 of those fifths because it's 1 2/5. Make sure I show that it's a whole up at the top. Now 1/2, I love halves because they're like the easiest model to draw, right? 1/2, perfect. And it's a 1 whole up here. Now, thinking of our multiples of 5/5, I always like counting by the larger unit, or the larger numbered unit. It's the smallest unit that we're counting by, because fifths are definitely smaller than halves, but the digit, the digit's larger. 5 is larger than 2. So we have fifths, 5, 10, 15. I'm just going to do that in my head instead of writing it down. Well, 2 goes into 10. So we know that tenths is what we're looking for. So if I think about that, I need to cut the fifths in half. So this equals 10 tenths. And this equals, well, if I cut each piece in half, I'm multiplying by 2. So that's 4 tenths. And for the halves, to create tenths, I need to cut 2 times every group into 5 pieces. 2 times 5 is going to give me 10. So I need 4 cuts. And 1/2 is equal to 5 tenths. Now let's just rewrite it. So I'm going to rewrite the sentence. So 1 4 tenths minus 5 tenths. Now I can't take 5 tenths away from 4 tenths as is, so I need to regroup those wholes into those tenths. So that should be 10 tenths plus 14 tenths, or oops, I gave you the answer. 10 tenths plus 4 tenths is 14 tenths minus the 5 tenths should give us 9 tenths. Okay, so let me just show that by taking away the 5. 1, 2, 3, 4, 5. Yeah, that would be 9 tenths. Perfect. All right, pause me, and I'm going to go work on the other 2, and you're going to go ahead and work on your own independently, and let's get rolling. All right, I didn't draw the models, and it's partly because I'm just trying to get this up and posted here as close to 8 a.m. as possible. But you can see the common unit in this first one that you were looking for is twelfths. And you should have been able to regroup and get that to be 11 twelfths. And down here, this one was kind of tricky because you didn't actually have to change the unit because eighths are already something halves can be created into 2, 4, 6, 8, right? So that one might have tricked you. But you didn't have to work that hard on that one. You only had to work with one fraction to create common units. And that created eighths, and our answer was 7/8. Let's go to the back. All right, 1 2/3. Let's do this one together, or let's do F together. 1 2/3. So create thirds real quick. There's one, there's my 3/3. There's my 2/3. So 3/3 and 2/3. Whoops, that's a bad 3. But that's, I'm already thinking that's 5/3, right? But it doesn't matter because we know we're going to rename that when I look at the other fraction, which is fifths, 3/5. So 4 cuts, 3/5. Let me scroll down a little bit so I can label. So now let's count by fifths. 5, 10, 15. This is why I've been saying since the beginning of the year, it's really important to know our multiples, our multiplication facts, 3, 6, 9, 12, 15. If you don't, it really slows you down. The fact that I can just roll those off the top of my head that fast really allows me just to work on the math pretty simply. But when you get clunked up here, then you are then also trying to figure out this at the same time. And learning 2 things at once is always a challenge. It's nice to just work on one thing. Okay, so it looks like thirds need to be cut 3 times to create 15ths, and fifths need to be cut 5 times. Whoops, I said that backwards. Fifths need to be cut 3 times to create 15ths. Thirds need to be cut 5 times to create 15ths. Or cut into 5 pieces, which is 4 cuts. I'm sorry, I'm messing it up here. 1, 2, 3, 4, and then over here, 1, 2. So 3/5 is now, I can see if I'm cutting each piece into 3, so I'm really multiplying by 3, 9/15. If I'm cutting each piece into 5, I'm really multiplying by 5. So we got 15/15 over here, which makes sense, it's a whole. And then multiplying by 5, 10/15. So if I rewrite this math sentence, let me use orange, that would be 1 10/15 minus 9/15. And we can see that we didn't actually have to regroup here because we have 10/15. So it's just 1 1/15 is this answer. Good, sorry, that got a little weird. All right, go ahead and pause me. Go ahead and try to do 1 2/7 and 1/3 to give you the hint. The common unit is going to be 21st. I know I said that wrong in the past. I was calling it 21ths, but it's really called 21st. All right. As you'll see, that answer created 20 21ths. I said it wrong again. I just corrected myself, 20/21. Again, that's not a fractional unit that you see a lot. So I know at the beginning I said we're going to do this word problem. We're not, because I believe that this is going to take too long. If you get done with your exit ticket and you have some time, so I'm going to write this, only if you have extra time. And if you do, submit this on top of your exit ticket. Submit it with your exit ticket if you have extra time, and I'll give you some extra credit. Okay, so if you submit that with your, whoa, I don't know what happened there. But if you submit it with your exit ticket, I'll give you extra credit, even if it's not right. If I see good effort, we'll give you extra credit. All right, looking at our exit ticket, there's two math problems. Drawing the rectangular fractional model, area model, AKA area model, and showing me the subtraction. And you can do it in either way, just by Xing them out or showing me numerically. All right, good luck today. Let me know if you need me via Zoom. I'm at my computer pretty much all day, unless I need to get up and let Bronson out. So let me know what you need from me, guys. All right, have a great day.